Welcome to our lesson on simultaneous equations, and we're going to be looking at solving simultaneous equations by substitution. Okay, now we in these two equations we have 2x plus y is equal to 6 and 3x plus 4y is equal to 19. Now if you notice, we have two variables here. We have a variable in x and a variable in y. Okay, hence we must have two equations to solve for our two variables, and we're going to solve them simultaneously. So when solving these equations, first I'm going to label my equations. I'm going to call this equation this is equation 1. Okay, and this is my second equation, I'm going to label it equation 2. Now, when solving by substitution, the key thing here is to make one of the variable the subject. However, I'm going to choose to make the easiest one. I could make any variable the subject. I could make x the subject in equation 1, I could make x the subject in equation 2, or y in equation 1, or y in equation 2. However, because the coefficient of y in equation 1 is basically 1, I would have a 1 here in front of the y. Okay, so it's easier to make y the subject in equation 1 because the coefficient, and when I speak about the coefficient, I mean the number in front of the variable, okay, is more than 1. In this one, x is more than 1, and the coefficient in equation 2 of x is the coefficient of x rather in equation 2 is greater than 1. So it would be best to make y the subject in equation 1. Okay, so my note here, I'm going to make a note. I'm going to say make y the subject in equation 1. Now my equation 1 would state 2x, I'm taking this equation here, 2x plus y, and that is equal to 6. Now I must transpose, so I'm going to take my 2x to this side, hence I will have y left over on this side. So in order for me to do that, I must now look at what 2x is doing to y, and I notice that it's being added. So I have to do the opposite of that. And the opposite of addition is subtraction. So to get 2x over on this side, I must subtract 2x from both sides of the equation. So I have a positive 2x minus 2x plus y is equal to 6. And I have subtracted 2x from this side, hence I must do it also to this side. Okay. Now, obviously, a positive 2x will cancel out with a negative 2x. So I am left with here y is equal to 6 minus 2x, and I can call that my equation 3. So I can just label this equation 3. Now, after I've completed that, the next thing I need to do now, I'm going to substitute my equation 3, which is y is equal to 6 minus 2x, into equation number 2. Alright, since I've made y the subject in equation 1, then wherever y is in equation 2, I'm going to put 6 minus 2x. So let's make another note here. Substitute y equal 6 minus 2x into equation 2. Now let's state what equation 2 says. In our equation 2 we have 3x plus 4y, and that is equal to 19. Okay, now if y is 6 minus 2x, then anywhere in this equation I see y, I can replace it with 6 minus 2x. So here now I'm going to say this is 3x. So we have 3x plus 4, and if you notice, the y is multiplying the 4, so I'm going to have open bracket, and I'm going to remove the y and put the the expression that y represents here, which is 6 minus 2x close bracket, and that must be equal to 19. So now I can just go ahead and use my distributive law here and expand this bracket. So I'm going to say this is 3x plus 4 times 6. So I'm using this 4 to multiply the 6. Okay, so I'm going to say 4 times 6. And 4 sixes, we have 24. Okay, and then I'm going to say 4 again times 2x, but this is a negative 2x, so a positive times a negative will always give me a negative, and 4 twos 8x, and that must be equal to 19. Now what I really have here, the leftover that I have here, I can just simplify my 3x and my negative 8x, so I will get a negative, let me just group my like terms, 3x minus 8x plus 24, and that is equal to 19. Okay, let's just take this up here. Let's just continue up top. So here where we left off, I have a 3x minus 8x, and that will give me a negative 5x, and plus 24, and that is equal to 19. Now I can move my 24 to this side, okay guys, and isolate my negative 5x. Okay, so I'm going to have negative 5x, but this 24 is being added to this negative 5x, so I must do the opposite of addition in order to move the 24, which is subtraction. So I'm going to subtract 24 from both sides of my equation. Okay, now I have a 24 minus 24, and that is equal to 19 minus 24. Now we all know that a positive 24 will cancel out with a negative 24, and I'll be left with a negative 5x is equal to 19 minus, okay, we can just calculate that. 19 minus 24, obviously we'll be left with a negative number, because the face value of the negative number is larger than the face value of the positive number. And what I mean by face value is when you look at the number, what do you see? I have a 24 here and I have a 19 there. So when you look at a number, the digit that you see, whatever you're seeing is called the face value. So I'll have a negative 5. Now I need the x alone to be isolated. I need x alone on this side, so I'm going to say, what is negative 5 doing to x? It is being multiplied, so I must do the opposite of multiplication, which is now division. And what I do to this side of my equation, I must do to the other side of my equation. So I have a negative 5 will cancel out with a negative 5. Therefore I have x is equal to negative divided by a negative will give me a positive, and 5 into itself goes once, and 5 into 5 1. So x is positive 1. Now if you notice, I have found the value of my x. My x is positive 1. Now I need to find the value of y. So I'm going to go back to my original equations, and remember, these two equations is the original equations. These two equations were given to us. Now what I'm going to do, I'm going to choose the simplest equation, okay, just to limit the risk to make any error. I'm going to choose one of the original equations, but I'm going to choose the simplest one to solve for y. And just by intuition, when you look at equation 1, it would seem to be the simplest. So I'm going to say substitute. Since I've found the value of x, now I can put x into any one of those equations and solve for y. So I have substitute x equal 1 into, and I'm going to put that into equation 1. Now equation 1 states that 2x plus y is equal to 6. So what this is saying, wherever x is, I can replace it and put 1. So I'm going to say 2 open bracket 1, because x is 2 is multiplying x, hence 2 is multiplying 1, which is the value for x, plus y, and that is equal to 6. Now I can simplify this by saying 2 ones 2 plus y, is equal to 6. Now if you notice 2 is being added to y, so I must do the opposite of addition, which is subtraction, in order to get my 2 to the next side. So I'm going to say 2 minus 2 plus y is equal to, and what I do to this side I must do to the other side, minus 2. And I'm going to get positive 2 will cancel out with negative 2, hence I have y left on this side. So y is equal to 6 minus 2. I'll be left with a 4. So therefore I can now state my answers that when x is equal to positive 1, which is this one here, okay, my y is equal to 4. Good. And we can always, and that's our answers, guys. It's really that easy when solving simultaneous equation by substitution. Now this what I'm going to be doing here. You're not required to do it on an exam paper. However, this is just for your own benefit, for your own confidence. Now you could always check yourself. Remember now that you are finished with the problem because you had found your solutions for both x and y. But just to check, and let me write here, you're just doing a check, and you can always do this on rough paper. You are not required to show this, just to check if your answers are correct. What you could do, you could take your original equations and plug in these values for x and y in both equations. It's very important that you try it with both equations, okay, and to see if you get back your solution or your answer out here, which is 6. So in equation 1 says 2x plus y must be equal to 6, and x is 1, so I can substitute, saying 2 1s 2 plus y is 4 plus 4 must be equal to 6. So I have 2 1s 2, 2 plus 4 is equal to 6. So there you have your solution. So that would be correct because you have tried it in equation 1 here, okay, and it works. Now let's try equation 2 to see if it works, if it really works. Okay, equation 2 states that 3x plus y is equal to 6. Okay, now what is x? X is 1, so you're going to say 3 open bracket 1, and you're going to, oh my bad, I should have a 4y there, okay, plus 4 times 4 is equal to 19. Now 3 1s is 3 plus 4 times 4, that's a 16, and it's very clear that 3 plus 16 is equal to 19. So again, we're good to go, and it's that easy. So there you have proven to yourselves that your solutions, they were correct, okay, because when you plug them in the original equation in both equation 1, so this would be equation 1 and this would be equation number 2, and both works out to be the same values that we have here for equation 1 and here for equation 2. Okay, thank you and bye bye.